Hello, this is Domenico with Easynomics, and we're going to continue looking at a payoff matrix as part of our discussion of oligopolies and strategic interdependent decision making and the role that game theory plays in helping economists and mathematicians understand the decisions and relationships between oligopolistic firms. Game theory is a mathematical technique. It analyzes the behavior of decision makers who are dependent on each other, and they use strategic behavior as a way to anticipate the behavior of their rivals. And this is applicable to oligopolies because since we have a small number of competing and large firms, they keep a very close eye on each other. And as a result, they make decisions based on what they think their competing firm may or may not do. And that interdependence in their decision making, we see in players in a game. Players making a decision in a game based on what they think their opponent may or may not do. So that gets into that idea of strategic interdependence. And we can illustrate this through a simple payoff matrix, as you can see here. And one example of illustrating the decisions made by two players in a game or two firms in a game is using the prisoner's dilemma. All right. So here we have two criminals that have been arrested by the police, criminal A and criminal B. They're being held temporarily in prison, and the police are keeping them in separate rooms in the hopes that one of them or both of them confess to the crime. And let's say that the police only have enough evidence to put both criminals in prison just for about a year. But they need more evidence, they need a confession, they need the details of the crime so that they can potentially put, hopefully, both prisoners into prison for a longer period. So we have in this rectangle 4 boxes, which are labeled 1, 2, 3, and 4, and it illustrates the outcome of a choice made by each player, criminal A and criminal B, and the outcome of their decision in relationship to the decision made by their partner, the partner that's been a partner in their crime. So there's only 2 options for these two that are held in prison by the police. One is to remain silent or to confess. So both criminals obviously would try to make an agreement with each other that if they're arrested, to remain silent, do not say anything, because that gives them the best outcome. And here we can see that in box number 1, if both criminal A remains silent and criminal B remains silent, they both get just 1 year in prison, all right, which is not potentially so bad. All right, so this is dependent on both players or both criminals maintaining silence under the pressure of the police trying to get a confession out of them. So that's the best option, and that's the best rational choice to be made by both sides, to cooperate and to hold, to not talk. What happens if they both confess? If both criminal A confesses to the crime and criminal B confesses to the crime, they both get 7 years in prison. They provide enough evidence for the police to put them away for 7 years in jail. And that is obviously the worst outcome. That's the worst thing that both criminal A and criminal B can do, is to confess. What happens if criminal A confesses and gives some information to the police while criminal B does not cooperate with the police and remains silent? Then criminal A is essentially ratting out on criminal B, cooperating with the police in order to get a jail out of free get a jail out of free card. So criminal A goes free while criminal B, remaining silent, gets 20 years in prison. And vice versa. If criminal B confesses while criminal A remains silent, then criminal B is rewarded for confessing and cooperating with the police. They get a free out of jail card. They go free from jail, while criminal A takes the heat and goes to prison for 20 years. So what should criminal A and criminal B do? Well, obviously the best rational option is to cooperate and to remain silent. But the police, knowing that there's this strong incentive for the two to, let's say, incentive to collude or the incentive to cooperate, they will keep them in separate rooms. So often you might see in a movie, they will keep two criminals in separate rooms so that they cannot communicate with each other and that they cannot gain information of what the other criminal has said or done with the police. So that's a police technique trying to increase the asymmetries of information, making sure that criminal A and criminal B cannot see or gain information about what the other is doing. And that works to the advantage of the police, because the police can then bluff or lie, let's say to criminal A, and they can tell criminal A, you know what? Criminal B has ratted out on you. They have confessed. And as a result of you not cooperating, you will take the heat of this crime and you will get 20 years in prison. So criminal A, hearing that from the police, thinking that criminal B has confessed and feeling the heat that they may get 20 years in prison, puts a lot of pressure on them to do what? To also confess. Now this could not be true. This could be untrue. The police could be bluffing to criminal A that criminal B has confessed, but criminal A does not know this. They are locked in an isolated room. And as they hear that pressure from the police that criminal B has ratted out on them, even though that may not be true, that puts pressure on criminal A to confess. Because if they confess while criminal B confesses, then they only get 7 years in prison as opposed to getting 20 years in prison and seeing the other criminal go free. All right, so that's the explanation of this payoff matrix. Now, what is the dominant strategy? The dominant strategy in this case would be for criminal A or criminal B to confess. Even though that's not the best rational option, it allows them to not face the consequence of getting 20 years in prison while watching their partner in crime go free. If they confess, they avoid the 20 years of prison, and if both confess, then they only get 7 years of prison as opposed to 20. The ideal would be to get 1 year, but you're not sure if you're going to get that 1 year if your partner in crime confesses against you. So the dominant strategy for both would be to confess, and the police know this. They put pressure on both criminals to ultimately confess, and they do succumb to the pressure, and they both confess, and they get the worst outcome, which is outcome box number 4, both getting 7 years in prison. So the dominant strategy here is to confess. And that confession by both sides takes us to box 4, which is the Nash Equilibrium in this particular payoff matrix. And the Nash Equilibrium is where both players gravitate towards as they devise their dominant strategy. So if these two criminals play this game and they think about the options and the potential consequences, they'll see that the best option for them is to confess in case their partner in crime confesses against them, so they end up in box number 4, which is the Nash Equilibrium. So both criminal A and criminal B will devise a strategy that's dominant, which is to confess. And that will take both of them to box number 4, which again is the Nash Equilibrium. Although box number 1 is the best rational option. Okay? So I'm going to go ahead and quickly explain this, perhaps maybe as we would for a paper exam, and then we'll go over how this payoff matrix can illustrate the conflicting incentives of oligopolies, which are the incentive to collude or cooperate and the conflicting incentive to cheat or to compete. So as can be seen, we have a payoff matrix illustrating the options available for two criminals. This illustrates the prisoner's dilemma. And the two criminals that have been captured by the police and being held in jail have two options, either to remain silent or to confess. If both criminal A and criminal B remain silent, then they end up in box number 1, where both criminal A and criminal B get 1 year in prison. right? The police only have enough evidence to convict them for 1 year. And because they've remained silent, then they've been able to avoid providing further evidence to the police to put them in prison for more time. If criminal A confesses, they succumb to pressure to the police, they cooperate with the police in the hopes that they can go free. Criminal A, if they confess, essentially ratting out criminal B while criminal B remains silent, then criminal A goes free. They don't face jail time, they're rewarded for cooperating with the police, while criminal B is punished for not cooperating with the police, and they take 20 years in prison. If criminal B decides to confess and cooperate with the police, while criminal A remains silent, then they end up in outcome box number 2, where criminal B goes free and criminal A gets 20 years in prison. If both criminal A and criminal B confess, they end up in box outcome number 4, where criminal A gets 7 years in prison and criminal B gets 7 years in prison. Because both prisoners are held in isolation and the police essentially lie to each prisoner, telling them that their partner in crime has confessed against them, that puts each criminal under pressure to confess, because if they don't, they may face 20 years in prison. If they both confess, leading to their dominant strategy, at least they only get 7 years of prison as opposed to 20. The best rational option is colluding, remaining silent, cooperating, and only getting 1 year, but because of the asymmetries of information, they confess. How does this relate to oligopolies? Well, oligopolies are a small number of large firms, and since they keep an eye on each other, there might be opportunities for them to collude, to cooperate, to work together, which is illegal in most if not all developed nations, but there's that incentive there to kind of work together secretly. If they can collude or cooperate, they limit or avoid competition. They avoid the uncertainties of not knowing what their behavior will or will not do. Since they're communicating with each other and stating what they will do, that avoids an uncertainty. And the collusion can entail them fixing prices, keeping prices high, both of them collectively agreeing to maintain high prices. Perhaps it could be to limit supply, to create shortages, to raise price again. Or they might collude to divide the market between them and not compete against each other in those markets. That allows the colluding oligopolies to essentially become a monopoly or a collective monopoly where they can sustain their supernormal profits. But there's also that conflicting incentive to cheat on the agreement, to try to secretly cheat on the agreement behind the backs of their colluding partners. And if they cheat, they may be able to increase their revenue by grabbing the market share of their rival. And if one cheats, then the other will cheat, and the collusion agreement will break, and they will fall towards the Nash Equilibrium of all firms cheating. Okay? So perhaps I'll create one more payoff matrix, or maybe a couple more, one more to illustrate the decisions made by firms to cooperate or to collude or to compete, to further illustrate this. And you have an earlier video illustrating the same idea between splitting and stealing in a game show and the best outcomes for the players in that particular game. And that's it. If you have any questions, feel free to comment, and don't forget to subscribe and to like. Thank you so much.